dear students. Today we are going to study about a new chapter, ray optics and optical instruments. Let me know about what is optics. Optics is the branch of physics which deals about light and certain phenomena related with light. What is optics? Optics is the branch of physics which deals about light and certain phenomena related with light like reflection, refraction, polarization, interference, etc. This optics can be divided into three branches. They are ray optics. This ray optics is also known as geometrical optics. Second one is wave optics. Wave optics is also known as physical optics. And third one is quantum optics. Quantum optics. Okay, let me know about one by one. Ray optics. Ray optics is a branch of optics which deals about light on the basis of ray nature. On the basis of ray nature. Wave optics is the branch of optics which deals about light on the basis of wave nature. And finally, quantum optics. Quantum means particle. So, quantum optics is the branch of optics which deals about light on the basis of particle nature. On the basis of particle nature. In this chapter, we will study about only ray optics and later we discuss about wave optics. Okay. What is ray optics? Ray optics is a branch of optics which deals about light on the basis of ray nature. Okay. Let me know about what is light. Light is a form of energy. What is light? Light is a form of energy which travels with enormous speed, that is 3 into 10 raised power of 8 meter per second in vacuum. Does the light travel straight? Yes. Light travels along a straight line. Light travels along a straight line. Yes. This property of light is known as rectilinear propagation. This property of light is known as rectilinear propagation of light. What is rectilinear propagation of light? Light travels along a straight line is known as rectilinear propagation of light. In homogeneous medium, light travels along a straight line. And this path is known as ray of light. This path is known as ray of light. Then what is ray of light? Ray of light is the path along which light travels. Path along which light travels. It is represented by a straight line with an arrow. This arrow indicates the direction of light. Okay. Light travels along a straight line. This arrow indicates direction of light. Then what is beam? Beam of light. This beam of light is the collection of rays or bundle of rays. Beam of rays is the collection of rays or bunch of rays or bundle of rays. This beam of rays can be divided into three groups. They are parallel beam of light, convergent beam of light and divergent beam of light. Beam of light can be divided into three types. They are parallel beam of light, convergent beam of light and divergent beam of light. Let me know about one by one. Parallel beam of light. In parallel beam of light, all the rays of light are parallel to each other. If all the rays of light are parallel to each other, then they are called parallel beam of light. In parallel beam of light, width between the two rays remains constant. Width between the two rays always remains constant. Best example for parallel beam of light is sunlight reaching the earth or laser light, etc. Okay. Next, convergent beam of light. If all the rays of light are converges at a point, if all the rays of light are meet at a point or converges at a point, then they are called as convergent beam of light. If all the rays of light are meet at a point, then they are known as convergent beam of light. And I will observe that in convergent beam of light, width between the two rays goes on decreases. Width between the two rays goes on decreases. But in the case of parallel beam of light, width remains constant. But in the case of convergent beam, width goes on decreases. Best example for convergent beam of light is sunlight. Not sunlight. Sunlight focused by a magnifying lens. Sunlight is an example for parallel beam of light. But sunlight focused by a magnifying lens is example for convergent beam of light. Next, third one is divergent beam of light. Okay. Divergent beam of light is opposite to this convergent beam of light. That means if all the rays of light are spreads over each other, all the rays of light are spread over each other, then they are called convergent beam of light. All the rays of light are spread over each other. And in figure, you will observe that the width between the two rays goes on increases. In the case of divergent beam of light, width between the two rays goes on increases. That means these rays never meet each other. Divergent beam of light never meet each other. Best example for this divergent beam of light is our torch light. I think it is clear now. It starts with reflection of light. Reflection of light is a very important phenomenon of light. What do you mean by reflection? Generally, this reflection means bouncing back. So, reflection of light means bouncing back of ray of light. For better understand this, for example, you take a ball in your hand and hits against a wall. What happens? Naturally, it bounces back. The same situation is observed in the reflection of light. Instead of ball, when ray of light incident on the surface, it gets reflected. This phenomenon is known as reflection of light. What is reflection of light? The bouncing back of ray of light is known as reflection of light. Or when a ray traveling in one medium and incident on the surface of other and returns back to the first medium is known as reflection of light. For that, let us consider a reflecting surface. Let us call this as plane mirror, any other surface. Okay, this is reflecting surface. Okay. This is the polished surface, that means silver surface, non-reflecting surface. This one is reflecting surface. When a ray of light incident on this surface, what happens? This incident ray gets reflected back. Incident ray gets reflected back like this. This point of incidence is called as O, and this incident ray is A, and this reflected ray is B. In the figure, AO is the incident ray, OB is the reflected ray. For our purpose, let us imagine to calculate the angle of incidence and angle of reflection, let us assume or let us draw an imaginary perpendicular line. Where you have to draw this imaginary perpendicular line? From here or here? No. We have to draw an imaginary perpendicular line at the point of incidence perpendicular to the reflecting surface. Let us draw an imaginary perpendicular line at the point of incidence perpendicular to the reflecting surface. Let us call this is MN. MN is the normal or perpendicular imaginary line. It is not a ray, it is only an imaginary line. Okay, now we shall measure the angle of incidence and angle of reflection with respect to the normal. Okay, this angle is known as angle of incidence, that is I, that is angle between the incident ray, angle between the incident ray and normal is known as angle of incidence. And similarly, angle between normal and angle between normal and reflected light is known as angle of reflection, that is I. Okay. Here I is the angle of incidence and R is the angle of reflection. This can also be written as theta, or this can also be written as theta. Okay. It is clear to you now. OA is the incident ray, OB is the reflected ray, and MN is the normal. Angle AOM is the incident angle, MOB is the reflected angle. When a ray of light incident on the reflecting surface at the point O, it gets reflected back to the same medium. Is it clear to you now? This figure, we will observe that the incident ray, reflected ray and normal all are lying in the same plane, that is the plane of the board like this. This is the first law of reflection. What is that? The incident ray, reflected ray and normal drawn to the surface at the point of incidence all are lying in the same plane. AO is the incident ray, OB is the reflected ray and MN all are lying in the same plane. We shall write here first law of reflection. First law of reflection. What is the statement of first law of reflection? Incident ray, reflected ray and normal drawn to the surface, all are lying in the same plane. Okay. Next, second law. Second law of reflection states that angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Okay, here angle of incidence is the angle between the incident ray and normal. Angle of reflection is the angle between reflected ray and normal. Second law states that angle of incidence is equal to angle of reflection. For example, if a ray of light incident at an angle 30 degree, then what will be the angle of reflection? Yes, you are right. Angle of refraction is exactly 30 degree. That means angle of incidence is equal to angle of reflection. Suppose when a ray of light incident at the surface at an angle of 40 degree, then what will be the angle of reflection? Yes, angle of reflection is also 40 degree. That means angle of incidence, angle of reflection are same. Okay. Now let us consider another example. This is our reflecting surface. Suppose when a ray of light incident at the surface along the normal. When a ray of light incident at the surface along the normal. Then what is the angle of incidence and angle of reflection? What is the value of angle of incidence and angle of reflection? Angle of incidence is equal to 0 degree and angle of reflection is also equal to 0 degree, because when a ray of light incident at the surface along normal means we measure the angle of incidence with respect to normal. Here angle of incidence is parallel to the normal, therefore angle of incidence value is 0 degree. When a ray of light incident along the normal, it gets bounces back with the same direction, it bounces back in opposite direction, exactly in opposite direction. That means it retraces its paths in opposite direction. So I is equal to 0 degree, R is equal to 0 degree. Again, this situation also follows reflection of light, that is angle of incidence is equal to angle of reflection. Okay. Let us start next concept, mirror. What is mirror? Mirror is a device which reflects the light. Mirror is a device which reflects the light. Okay. There are two types of mirror. They are plane mirror and spherical mirror. There are two types of mirror. They are plane mirror and spherical mirror. Let me know about plane mirror. What is plane mirror? If reflecting surface is plane, then it is known as plane mirror. This is the plane mirror. This slanted line indicates the non-reflecting surface and this line indicates the reflecting surface. A mirror whose reflecting surface is plane is known as plane mirror. For example, suppose if you stand in front of a mirror, what you will see? You will see your image. And in your image, you will observe that size of the image and size of the object both are same. In plane mirror, size of image and size of object both are same. Similarly, height of object and height of image both are same. And also suppose the distance between the object distance and image distance are same. To confirm this, you do one thing. You will stand in front of mirror by holding 1 meter scale and your image is also hold 1 meter scale. That means object distance and image distance both are same. Okay. And the image is erect. Image is erect and you will observe laterally shifted image. You will in the plane mirror you will observe laterally shifted image. Laterally shifted image means your left portion appears as right and right portion appears as left. That is known as laterally shifted. Okay. What are the conditions for plane mirror? There are 4 conditions. There is size of the image and size of the object are same. Object distance and image distance are same. Erect and you will observe laterally shifted image. Okay. But here the important concept is spherical mirror. Important concept is spherical mirror. Okay. What is spherical mirror? Spherical mirror is one whose surface forms a part of sphere. Whose surface forms a part of sphere. Spherical mirror is one whose surface forms a part of sphere. To better understand this, let us take a ball like rubber ball or cricket ball like this. Okay. Let us assume this ball is made up of glass. Let us assume this ball is made up of glass and cut a small portion of this ball. What you will get? You will get a bowl-shaped arrangement like this. You will get a bowl-shaped arrangement like this. This is known as spherical mirror. This portion is known as spherical mirror. Okay. Did you got my point? Okay. Next, types of mirror. There are 2 types of mirror. There are 2 types of mirror. They are concave mirror and convex mirror. There are 2 types of mirror. They are concave mirror and convex mirror. Let me know about what is concave mirror. Concave mirror is one whose inner surface is reflecting. Concave mirror is one whose inner surface is reflecting and outer surface is non-reflecting, that is painted or silver. That is a non-reflecting surface. Only inner side is reflecting. Second one is convex mirror. Second one is convex mirror. Convex mirror means whose outer surface is reflecting and inner surface is non-reflecting like this. In convex mirror, outer surface is reflecting and inner surface is non-reflecting. Okay, let us discuss about some basic terminologies which are related to both concave and convex mirror. Okay, for that let us consider or let us draw a concave mirror like this. Let us draw a concave mirror whose outer surface is non-reflecting, that is silver, and inner surface is reflecting. The geometric midpoint of this concave mirror is known as pole. Geometric midpoint of the concave mirror is known as pole. It is represented by P. Okay. What is pole? Pole is the geometric midpoint of the concave mirror or mirror. Okay. Next, center of curvature. Second point is center of curvature. Center of curvature is the center of the sphere for which it forms a part of sphere. You already know that this mirror is a part of sphere. So let me imagine a sphere like this. The center of sphere, this sphere is here, that is C. This is known as center of curvature. Center of curvature is the center of sphere of which mirror is a part. Okay, the center of curvature is denoted by the letter C. Okay, next one is radius of curvature. Radius of curvature. This radius of curvature is denoted with the letter R. Radius of curvature is the distance between the pole and center of curvature. Radius of curvature is the distance between the pole and center of curvature. Okay. Next, fourth one is principal axis. Fourth one is principal axis. Okay. This principal axis is the straight line joining the center of curvature and pole. What is principal axis? It is a straight line joining the pole and center of curvature. Okay, these are the very important basic terminologies which are related to both concave and convex mirror. Okay, you will define the same terms with respect to convex mirror also. Okay, let me refresh once again. What is pole? Pole is a geometric midpoint of the mirror. What is center of curvature? Center of curvature is the center of the mirror, which center of the sphere of which mirror is a part. And third one is radius of curvature. Radius of curvature is the distance between the pole and center of curvature. And fourth one is principal axis. Principal axis is the straight line joining the center of curvature and pole. The circle is not necessary, but for your convenience you will draw. Okay. Next, the same situations are also applied for convex mirror. For example, let us draw a convex mirror like this. Its inner surface is reflecting and this is the outer surface of the convex mirror. Okay. When this is the geometrical midpoint. That the geometrical midpoint is known as pole. And let you define pole. What is pole? Pole is the geometrical midpoint. Let us imagine a circle here like this. This is the central part. Again, this central part is known as center of curvature, and the distance between the pole and center is known as radius of curvature. The line joining the pole and center of curvature is known as principal axis. Now it is clear for you. Principal focus. Let us draw a concave mirror like this. This is the outer surface of the concave mirror, that is non-reflecting. This is the inner portion which is reflecting. I already know that this is the midpoint of the spherical surface, is known as pole, and this one is the center of curvature C. This is center of curvature C, and the distance between center of curvature and pole is known as R, that is radius of curvature, and the line joining the center of curvature and principal axis is known as principal. So center of curvature and pole is known as principal axis. When a parallel beam of light is incident on the spherical surface, what happens? When a parallel beam of light is incident on the spherical surface, this parallel beam of light is known as paraxial rays. Paraxial rays means the rays which are close to the principal axis. What is paraxial rays? The parallel beam of light which are very close to the principal axis is known as paraxial ray of light. Okay. When a parallel beam of light incident on the spherical surface, it gets reflected back. Like this. Suppose another ray of light incident here. Again, it gets reflected back. Like this. That means these rays, the reflected rays are focused. That means they are meet at a point. The reflected light are meet at a point. That point is known as focus. When a parallel beam of light incident on the spherical surface, the reflected light is the incident light and these are the reflected rays. These reflected rays are focused at a point or appears to meet at a point. That point is known as principal focus or simply focus. What is principal focus? When a parallel beam of light incident on this spherical surface, the reflected ray meet at a point on the principal axis. That point is known as principal focus or simply for convex mirror like this. This is the silvered portion or painted portion. This is the reflecting surface. So this is the principal axis and this is the pole. This one is the center of curvature and distance is known as radius of curvature. When a parallel beam of light incident on this convex mirror, it gets reflected back like this. It gets reflected back. Similarly, when a ray of light incident on the parallel beam of light incident on the spherical surface, that is convex mirror, it gets reflected back like this. What happens? This reflected ray appears to diverge from a point. This reflected rays appear to diverge from a point. They are reflected in the surface, but they appear to diverge from a point. That point is known as principal focus. That point is known as principal focus. Okay, but in case of concave mirror, they really meet. But in the case of convex mirror, they appear to diverge like this. They appear to diverge. Okay, so what is principal focus? So principal focus is when a parallel beam of light incident on the concave mirror or convex mirror, it gets reflected back and meet at a point or appears to diverge from a point, and that point is known as principal focus. Shall I repeat once again? When a parallel beam of light incident on either concave mirror or convex mirror, it gets reflected back and they meet at a point or appears to diverge from a point, and that point is known as principal focus or simply focus. That focus is represented by capital F. Okay. Now the distance between the principal pole and principal focus is known as focal length. It is represented by small f. What is focal length? Focal length is the distance between the principal pole and focus. Focal length is the distance between the pole and principal focus. Okay. What is principal focal length? It is the distance between the pole and principal focus. Length is the distance between the principal focus, pole and principal focus. It is represented by small f. Don't confuse with capital F. Capital F is the principal focus and small f is the focal length. Okay, I think you already know that for a plane mirror like this is the incident ray. This is the reflected ray and this one is the perpendicular line, that is normal, to calculate the angle of incidence and angle of reflection. For spherical surface, where you have to draw this normal line, for spherical surface, where you have to draw this normal line? We have to draw this normal lines from the center of curvature. We have to draw the normal line from the center of curvature to the point of incidence. This is the normal line for the spherical surface. You have to draw this normal line from the center of curvature to the point of incidence. Okay. So now this is the angle of incidence, or this can be called as theta or I. This is the angle of reflection, that is R. Okay. Angle of reflection, this can also be written as theta. For here also, the normal line is this. The line between it is drawn from center of curvature to the point of incidence like this. We have to draw this normal of incidence like this. This is the angle of incidence and this one is the angle of reflection.